In 1939, at a moment when the American railroad industry was still almost entirely dependent on steam, when the largest and most powerful locomotives in the world were all steam machines, when the idea that diesel could replace steam on a comprehensive scale was more theoretical than practical, Electromotive Division of General Motors introduced a locomotive that would, over the following decade, transform that dependence into obsolescence. The locomotive was called the FT, and its significance does not reside in its being the most powerful or the fastest or the most advanced. Its significance resides in what it proved about the future of railroad motive power, and in the way that proof forced the entire American railroad industry toward a decision that no single railroad wanted to make, but that all of them were compelled to make through the relentless logic of economic advantage. To understand what the FT represented, you have to understand the context in which it was introduced. The streamliners had demonstrated in the mid-1930s that diesel-electric traction could be applied to passenger service with spectacular results. The Burlington Zephyr, the Hiawatha, the 20th Century Limited, these were machines that captured public imagination and established that diesel could operate at speeds and with a reliability that rivaled or exceeded what steam could accomplish in the most prestigious services. But passenger service, for all its glamour and all its cultural significance, represented a small fraction of what American railroads actually did. The overwhelming majority of railroad work was freight, moving coal and grain and manufactured goods across the continent in quantities that defined the economic foundation of every major railroad in the country. Freight locomotives were different from passenger locomotives in every way that mattered. Where passenger locomotives could be optimized for speed and schedule reliability, freight locomotives had to be optimized for power and load capacity. A passenger train might be 5 or 6 cars at high speed. A freight train might be 80 or 100 cars at lower speed, on grades that required enormous tractive effort to move. Steam had evolved over more than a century into a family of machines specifically designed for this work. The 282 Mikado type, the 2102 Santa Fe type, the 2104 Texas type. These were massive machines that incorporated everything that a century of steam development had learned about moving heavy trains. They were powerful. They were reliable under harsh conditions. They were thoroughly understood by the men who operated and maintained them. The question that EMD's engineers faced in the late 1930s was whether a diesel could be built that could do what these massive steam machines could do. The streamliners had proved that diesel could be reliable and efficient in passenger service, but passenger service had never challenged the fundamental limits of mechanical design the way that freight service did. A diesel freight locomotive would have to produce tractive effort that steam was producing, would have to sustain that effort over extended periods on grades that tested the limits of what traction the rails could provide, would have to do this using electrical transmission systems that had never been pushed to the scale and power levels that freight service would require. The design that EMD's engineering department developed in response to this challenge was the FT, and it embodied some fundamental decisions about how to approach the problem of building a universal diesel freight locomotive. The most important decision was that the FT would not be a single massive locomotive like the biggest steam machines. The FT would be a unit, one of a number of identical units that could be coupled together in multiple unit, consists to produce whatever total power a given service required. This modular approach was not new. It had been developed in the streamliners and in other passenger diesels, but applying it to freight service, to the kind of heavy pulling work that freight imposed, was new and untested. The advantage of the modular approach was profound, though it was not immediately obvious to observers who were used to thinking about locomotives as individual machines. By using multiple standard units, EMD created a system in which any railroad could build whatever consist it needed by coupling together however many FTs were required for a given service. 2 units for light freight, 3 for medium freight, 4 or 5 for the heaviest coal drags. The maintenance advantage was equally profound. A railroad that operated a fleet of FT units only had to maintain expertise on a single power plant design. All of the FTs used the same diesel engine, the same electrical transmission, the same running gear, the same parts. The knowledge that a maintenance worker accumulated in servicing one FT could be applied directly to servicing any other FT. This was a revolutionary advantage over the maintenance of steam, where each class of locomotive had its own specific characteristics, and where understanding one design did not necessarily transfer to understanding another. The engine that EMD chose for the FT was a 1,350 horsepower 16-cylinder diesel, and at the time it was the largest diesel engine that had been proven in service conditions. The transmission was an electrical system in which the diesel engine drove a generator that supplied electrical power to traction motors connected to the wheels, a system that provided the smooth acceleration and the continuous variable control that electrical transmission provided. The result was a unit that produced 1,350 horsepower, and that could be coupled with other units to scale that power up to whatever level a service required. When EMD began demonstrating the FT in 1939, it did something that was both operationally bold and commercially shrewd. Instead of simply showing the FT's specifications and asking railroads to order them on faith, EMD offered to let railroads test FTs in actual revenue service, to haul real trains over real routes, to compare the FT's performance directly against steam locomotives that the railroads were currently using. The offer was accepted by a number of major railroads, each of which wanted to evaluate what the FT could actually accomplish in the specific service conditions that their railroad presented. The results of these tests were consistent across different railroads and different service types. The FT consumed significantly less fuel than the steam locomotive it was being compared to. The FT required less crew attention during operation. The FT required less maintenance between major service periods. The FT's reliability was equivalent to or better than steam. The speeds that the FT sustained were adequate for freight service, not dramatically faster than steam, but fast enough that the overall scheduled time for trains was reduced. And the FT's initial cost, while high, was offset over the locomotive's service life by the reduction in operating and maintenance costs. These results were not hypothetical. They were measured, documented, real. The railroads that conducted the tests understood that they were looking at evidence of something that challenged the entire framework of decisions that the American railroad industry had been making for more than a century. Steam had always been assumed to be the foundation of freight operations. The FT was proving that steam was not a necessary foundation, that it was possible to build a diesel that could replace steam in freight service and do so in a way that was economically superior. What happened in the years after the FT's introduction was not a sudden and complete switch to diesel. It was a series of individual decisions made by railroad management across the American system, decisions that were influenced by the FT's proven performance, but that were made in the context of each railroad's specific circumstances and specific capital availability. Some railroads ordered FTs immediately, recognizing the advantage and committing to a transition toward diesel. Other railroads were more cautious, ordering a limited number of FTs to test the technology in their own operations before committing to a larger transition. Some railroads continued ordering new steam locomotives into the mid-1940s, reluctant to abandon a technology they understood completely, and that was continuing to serve them adequately, even if not optimally. But the cumulative effect of these decisions, made independently by hundreds of railroad managers across the American system, was the beginning of a transition that would become, within a decade, comprehensive and irreversible. Railroads that ordered FTs discovered that the advantage was real, that the FT's performance translated into dollars saved in operating costs and in maintenance. Railroads that ordered FTs found that the modular design meant they could build their fleets from combinations of units that they could match their motive power to their service requirements with a precision that was not possible with steam, where each locomotive was an independent decision about which class to order and how many of that class to acquire. The competitive response from the established locomotive builders was muted and late. The major steam locomotive builders, Lima and Baldwin, could see what was happening. They understood that the FT represented a challenge to their business. That if railroads were ordering FTs, they were not ordering new steam locomotives. Lima attempted to compete by producing diesel freight locomotives of its own design. Baldwin attempted to compete by producing its own diesels. But both of these efforts were hampered by the fact that EMD had already established relationships with railroads, had demonstrated the FT in actual service, and had built a reputation for quality and reliability that competitors found difficult to overcome. What EMD had done through the FT and through the demonstration program that surrounded it was to establish a business model that competitors could not easily match. EMD offered a complete package: the locomotives themselves, the technical support to integrate them into railroad operations, the parts supply to maintain them, the training programs to teach railroad workers how to operate and maintain them. The FT was not just a machine, it was a system, and the system was designed to make any railroad that adopted it dependent on EMD for ongoing support and parts and expertise. This business model was extraordinarily effective, and it ensured that once a railroad committed to FTs, it was difficult for that railroad to switch to competitors. A railroad that had built its entire maintenance infrastructure around servicing electromotive diesels, that had trained its workers on EMD equipment, that had stocked parts for EMD locomotives, was not going to suddenly switch to Lima or Baldwin. The switching costs, in terms of retraining and reconfiguring maintenance facilities, were substantial enough that a railroad that went with EMD was essentially locked into EMD for the future. The Second World War accelerated the transition, though not in the way that some accounts suggest. The war did not suddenly force railroads to go diesel. What the war did was consume the capacity of the American locomotive building industry in ways that made steam locomotive production difficult, and that directed investment toward diesel production. Railroads that would have continued to order new steam locomotives found that steam production was constrained by the war effort, and were thus forced to consider diesel alternatives earlier than they might have otherwise chosen to. By the end of the war, in 1945, the FT had been joined by other diesel designs, some from EMD and some from competitors. The FT itself had been refined through the testing and operation that had occurred since 1939, and later versions incorporated improvements that had been learned through actual service. But the basic design, the modular approach, the standardization that the FT represented, had established itself as the direction that American railroads were moving. The question in 1945 was no longer whether railroads would transition to diesel. The question was simply how fast the transition would occur and how complete it would be. What happened in the years between 1945 and 1960 was the most rapid wholesale replacement of one technology with another that American industry has ever accomplished. The FT and its successors, the similar designs from EMD and the competitive attempts from Lima and Alco, distributed themselves across the American railroad system. Railroads that had ordered FTs in the early days discovered that the performance advantage translated into real financial benefits. Railroads that had been reluctant discovered that they could not compete with railroads that had gone diesel, that the cost advantage of diesel operation meant that railroads operating steam were at a structural disadvantage in terms of profitability and competitive position. The knowledge of how to operate steam was concentrated in smaller and smaller segments of the industry. The generation of workers who had been trained in steam operation from the beginning of their careers began to retire and was not replaced by new workers trained in steam. Railroads stopped ordering new steam locomotives because they had committed their capital to diesel. The infrastructure that maintained steam locomotives was dismantled as the machines it served were retired. Within 15 years, steam had gone from being the foundation of American freight operations to being essentially gone. A technology that persisted only in the machines that had been built before the transition and that were gradually being scrapped as they wore out. The FT, which had started the transition, was itself obsolete by the 1960s. Better diesel designs had been developed. More powerful units had been built. The specific horsepower and design characteristics that the FT had represented were exceeded by later machines. But the FT's significance did not reside in its technical specifications. Its significance resided in what it proved, which was that diesel could replace steam universally, that a single design approach could be scaled to handle any service that steam had traditionally handled, and that once this was proved, the future of steam was a matter of how long the existing machines would continue to operate, not a question of whether new steam would be built. The FT was not famous in the way that the streamliners were famous. It did not set records. It did not attract the public attention that high-speed passenger trains attracted. It was a working machine, operated on ordinary routes, carrying freight that nobody was particularly interested in by ordinary crews doing ordinary work. And yet, the FT was more historically significant than any streamliner, more important to the trajectory of American railroads than any machine that set records or captured attention. The FT was the machine that made the continuation of steam into the post-war era impossible, that forced the railroad industry toward diesel, not through any explicit coordinated decision, but through the relentless demonstration that there was no job steam could do, that diesel could not do better, cheaper, and more reliably. The FT accomplished this not through revolutionary design or through any dramatic innovation. The FT accomplished it through the straightforward and meticulous application of proven engineering to a problem that steam could solve, but that diesel could solve more efficiently. The FT proved that the age of steam could end not because the machines had failed, but because better machines could be built to replace them. And once that was proved, the only question remaining was how to manage the transition, not whether the transition would occur. That is the story of the FT, the diesel that made choice impossible, the machine that ended an era without drama through relentless demonstration of superiority in every dimension that mattered to the people who had to make the decisions. When the last steam locomotive was scrapped, decades of history had passed since the FT first proved that steam's future was limited. But the beginning of the end came in 1939, when EMD put the FT on the rails and asked railroads to compare it against the machines that had always been their foundation. The comparison, once made, was decisive, and nothing in American railroading was ever the same again.